What is inductor? It is a two-terminal passive device. Whenever the current flowing through it, it generates magnetic field and stores the electrical energy in the form of magnetic energy, and this generated magnetic flux due to magnetic field is directly proportional to the current flow. The change in current flow will cause change in magnetic flux, and this change in magnetic flux will induce electromotive force or EMF, but in reverse direction. So this induced EMF in reverse direction will finally oppose the change in current flow. So this phenomena of inductor to oppose the change in current flow is known as inductance. So we can say now the inductance of an inductor opposes the change in current flow. Its SI unit is Henry, kept on the name of American scientist Joseph Henry. Inductor having higher inductance will induce more EMF, which will oppose more to the current flow. And this inductance depends on many factors. In this formula we can see this inductance L depends on number of turns, the cross-sectional area of the inductor, and the length of the inductor. Since this inductance is directly proportional to the number of turns, so this inductor which is having more number of turns on it will have greater inductance, and it is inversely proportional to the length of the inductor. So inductor having longer length will have comparatively less inductance, and inductor having more cross-sectional area will have greater inductance value. And this inductance depends on one more factor, the material used for the core. The air core inductor will be having lesser inductance value compared to iron core inductor or ferrite core inductor. Let's see some use cases of inductor. Since the induced EMF blocks the change in current, it doesn't allow the AC signal flowing through it. So this inductor in series is used for DC filter. It filters out the ripple coming from the rectifier and gives a stable DC output to the load. Next, let's see the use case of this inductor in the tube light as a choke. To understand the role of choke here, first understand the working principle of this tube light. This tube light is made of mercury vapor gas, which is more resistive to the current flow. So whenever we switch on this circuit, a very high voltage is applied to the filaments present at both sides, which produces heat inside the tube light, and due to this heat, mercury vapor gas gets ionized, and the time it is fully ionized, it will provide no resistance further and works like a short circuit. So suppose this choke is not present, then very high current will be flowing through this tube light, which will damage it. So now the role of choke comes here. Once the mercury vapor gets ionized, it will offer less resistance, and due to this lesser resistance, the current flow will try to increase. And since choke is connected here, it will provide induced EMF, which will try to block the change in current flow. So this is how choke connected in the series with the tube light protects from the damage. Till now we have discussed about self-inductance, means inductance within the coil. Let's see the second scenario of mutual inductance. Whenever two coils are present nearby and current flows through the one coil, will generate the magnetic field across it, and this generated magnetic field into the first coil also gets induced into the nearby coil, which will induce the EMF in coil 2 also. So we can say the change in current flow in first coil induces the EMF in second coil. So this phenomenon is known as mutual inductance, and this mutual inductance also depends on the number of turns. Due to this characteristic of mutual inductance, transformer is able to transfer the energy from primary side to secondary side. In the step-up transformer, secondary side is having more turns, will generate higher EMF at secondary side, and the step-down transformer will generate lower EMF at secondary side.